Hello, welcome to our YouTube presentation. We are MomoWorks, and this is our foot drop device.
Current devices are compatible with only barefoot or shoe use cases. Our design improves on this by allowing the user to switch between being barefoot, wearing sandals, and wearing closed-toed shoes without having to switch out the ankle brace.
Right now, my foot is in a relaxed position and my toe is pointing down. If I press the boa ratchet down and tighten the strings will hold tension on my toes. And as I release my foot up, my foot stays in a flexed position. With the design of the toe sock, this device can be worn with sandals or barefoot as opposed to the existing models out there that require closed-toe shoes.
All right, so here you can see bottom housing for the ratchet with a post that the spring and pawl will go onto. This is the top housing for the bow ratchet and has some slots and a post in the middle. Here's the gear for the bow ratchet. And finally, here's the full assembly of the ankle brace, hooks, bow ratchet, and foot glove and velcro.
Here we have the full ratchet assembly. We have the top housing and the gear concentric with the center axis of the bottom housing. We also have the pawl arm and the torsional spring, which is concentric with the post on the bottom housing. Here is an unexploded view. Here is an animation of the ratchet assembly with the top housing hidden. Through this animation, we can see how the torsional spring keeps the pawl arm pressed against the gear as it rotates. This allows the gear to rotate clockwise and stops counterclockwise rotation until the arm is released.
So this is a simulation of the foot glove and velcro strap sewn together. I have all of the inside of the foot as fixed points because it will be on the ground or suspended. The force will be applied to this inside face of the velcro strap, where the force is 7 newtons. And so here you can see the stresses, but we don't have to worry about it because it is reinforced with sewing and a pliable material. We have the displacement. Top lip lifts up, but we don't have to worry about that because it is Velcro and they will stay together. And finally, we have the strain, where most of the strain is on the attachment point between the Velcro strap and the foot glove, but we can see no critical failing points.
The Velcro strap, shown here on the foot glove, experiences the most force on the edge facing the brace. During the manufacturing process, reinforcement of that area was paramount in order to maintain device stability. We also bought toe socks that had a leather reinforcement to provide the stability to that area. Fully defined parts streamline manufacturing and accurate simulations. A common scale of dimensions between multiple components allow for assemblies that fit together and make sense as a device. The size of the hammer arm had to be the same as the notches in the gear in order for the ratchet to function properly. When a material is manufactured, the upper and lower limit of the size is defined. Based on the tolerances, manufacturing methods can be chosen based on the accuracy required. Tolerances can be calculated using the common data point and the part, or in a more common part by looking it up in the engineering handbooks. They ensure that parts fit together in a physical assembly.
Our team was able to cooperate and coordinate to follow the path of idea to product. We each chose a part to design, then collaborated on the assembly and drawings. We met multiple times a week in order to discuss our progress and to assign new jobs if necessary. Thank you for watching our presentation.